Hello everyone, we are with the ninth module of the series, that is structural modeling, and let's get started with it. In this chapter, we'll be learning how to implement structural modeling with the help of various constructs like gate instantiation, UDP instantiation, and module instantiation. Module defines a basic unit in Verilog. It is on the form this much, and we have talked about this earlier. The port list gives a list of port through which the module communicates with external. Port can be declared as an input, output. A port by default is a net. However, it can be explicitly declared as a net, or an output or input port can optionally be redeclared as a register type in either the net declaration or the register declaration of the net or register must have the same as the one in the port declaration. And here is an example of here where the PC, INS and XTD are the port, where PC is later made into an 4-bit declared as 4-bit port, and our out inster is declared as a 9-bit port, and again and ADR is on as a 16-bit with both in-out capabilities. Then other than that, you can see we have converted it into in XADR into a wire, and in INSTR as an rhythm. Model instantiation. Model can be instituted by another module thus by creating an hierarchy. You can see the syntax here. Port associated a module by position or name, or however the association cannot be mixed, where port expression can be of the following: an identifier, a bit select, part select, concatenation of the above. An expression only for input port. Right. In positional association, the port expression connects to the port of the module in specified order. In associated by name, the connection between the module port and the port expression is explicitly specifies that the order of port association is not important. Module H, A, B, S and C, input A and B, output S and C, parameter and delay equal to 1, XOR delay equal to 2, XOR delay S is equal to A XOR B, and delay C, A and B. Module F, A, P, comma Q, C in sum, C out, where input are P, Q and C in sum is equal to sum and C out, parameter or delay equal to 1, YR is equal to S1, C1, C2. To module instantiation, HA is equal to H1, P, Q, S1, C1 associated by position, and this are associated by name, etc. or get instantiation as shown here. In the first module, the instantiation, unconnected port. Unconnected port is a necessity that can be made by specifying leaving the port as blank, which as you could see here, Q bar is not connected, so input preset somewhere is X. Different port length. When a port and the local port expression are of different length, port matching is performed by unsigned right justification or truncation, as you could see here. Then the module parameter value. When a module is instantiated in another module, the higher level module can change the value of the parameter. The lower list can be done by def param and the module instantiation parameter assignment. Def param is of the form different hierarchy. One part is equal to value 1 of into hierarchical part names of parameter in a lower level module can be explicitly set by using such a statement. Module instantiation parameter assignment. In this value, the new parameter values are specified in the module instantiation itself. You could see here. External port. In the module instance definition we have seen so far, the port list describes the list of port. For example, this much. The module AP, which here these are also external ports in an instantiation, and the external port names are used to specify the interconnections by associating by name. An example of instantiation is CRAM SA is equal to byte B1, memory BL M1 to control C1 and ARP A1. An internal port name not only can be used as identifier but also can be used as a following a bit select, part select, concatenation of bit select and part select, as you can see here. Finally, let's take an example of a decade counter written in structural design. The logic diagram, as you can see here. Here, as you can see, we have decade counter. We have the two ports, clock and Z. Where clock is input, output is Z, which is of 4-bit. There were two wires, S1 and S2, and AND gate is been declared A1 whose output is S1 and inputs are Z2 and Z1, and 4 modular instruction of JK flip-flops are done where J is connected to this, J is given this value, K is given to clock is given that, Q is equal to that, then this similarly this, and this is the module, so here is the final output. Then another example of 3 to update which we can see here. So that's we've come to end of our this module, and we'll continue with the next with another module in the next. So please hang on.